All right, and with that, we're going to go ahead and move on to our next presentation, which will be from Juliana Zolopa. And she's also a PIF's Young Scientist Opportunity intern. And today she's going to be talking about why sharks attack, environmental drivers of shark-human interactions. So I'm very excited. After we were just hearing about sharks from Kelsey's perspective, it'll be cool to hear it from a different perspective. So I'll go ahead and take it. You can take it away.
Okay, does that show up okay for everybody? All right, great. Hi, my name is Juliana Zolopa, and today I'll be talking about why sharks attack, environmental drivers of shark-human interactions in Hawaii. I'd just like to start out by thanking my mentors, Don Kobayashi, Kisei Tanaka, and Joy Smith, who made this project possible and helped me out through the whole thing. This project actually started out with some interest from National Geographic, who wanted to know more about a series of 3 unusual cookie cutter shark bites on swimmers attempting the Kaiwi Channel crossing between Oahu and Molokai. Cookie cutter shark bites on live human beings are really rare. And cookie cutter shark bites themselves are easily identifiable because of their unique shape and clean edges, and they achieve this with a row of sharp lower teeth, hook-like upper teeth, and unique lips that allow for suction, which you can kind of see demonstrated in that top left picture. Cookie cutter sharks are globally distributed in tropical to subtropical waters around the world, and they are generally thought to be vertical migrators, which means they spend most of their time at depth and come up at night to feed. They feed on a variety of organisms from different trophic levels because of their unique feeding strategy. The most common way for humans to interact with cookie cutter sharks is actually through bites on fishing catches, which you can kind of see in the lower left picture. And you can also see the variety of shapes that cookie cutter shark bites can be. They can be more perfectly circular or more oblong. The other way that humans typically interact with cookie cutter sharks is with bites on gear. So this lower right picture is actually a picture of the end of a cob trawl net that's been bitten by a cookie cutter shark. From there, we decided to look more broadly at shark-human interactions in Hawaii, and we did so using the DAR database of shark-human interactions. And so this collects information about date and time, location, species involved with an interaction. And from there, we generated this plot. And you can kind of see we have total interactions on the x-axis here from 1995 to the present and the different species that were involved. And tiger sharks are implicated in a lot of these interactions. There's a few reasons why this might be. Large, mature tiger sharks are common here in the main Hawaiian Islands because there's good breeding grounds here and also because Hawaii is so geographically isolated. Also in Maui specifically, where a lot of shark-human interactions take place, there are lots of small and more localized tiger sharks that overlap with beaches that are common for human use. So with that, we decided to look at shark-human interactions in Hawaii more generally. The first set of influences we looked at was temporal, and we analyzed these using generalized linear models. So this first plot shows total shark-human interactions over the years. And as you can see, there's a general upward trend, which makes sense as human population is upward trending. But you can also see a sort of interesting cyclical pattern that emerges. So it'll peak in some years and then dip down and then go up again. It's also interesting to look at tiger sharks more specifically. Again, it makes sense that in years with more shark-human interactions, we have more tiger sharks involved, but also even in more recent, even in lower recent years like 2017 and 2018, we still seem to have more tiger sharks than comparative previous years. This next plot, we decided to look at time of day. And so we had dawn, which was 5 a.m. to 7 a.m., morning, which was 8 a.m. to 11 a.m., afternoon, 12 p.m. to 4 p.m., sunset, 5 p.m. to 7 p.m., and night, which is all other hours. And so there's an obvious peak in the morning and afternoon for shark-human interactions. And this is most likely due to human beach use. This is when there's going to be more people at the beach and in the water, and so more interactions take place. The next set of influences we looked at were the human and spatial element, and again, we use generalized linear models. So this plot here, we have the islands on the x-axis and total interactions, and also broken down by activity types. So we have surfing, shore-based activities, which was things like wading or fishing, deep water fishing, which included things like spearfishing, service-based activities like swimming or snorkeling, and also paddling. And so as you can see, we have a lot more of the surfing and at the surface-based activities. This is likely because there's just a lot of these activities going on, and also because these activities put people in the water for extended periods of time. Also, interestingly, the main Hawaiian Islands, or the more populated Hawaiian Islands, had the most interactions. But interestingly, Maui had the most interactions despite being the third most populated island. This could have something to do with the fact that there's the large tiger shark presence there, and there's also proportionally a lot of tourism. And when tourists come, they spend a lot of time at the beach and in the water. So this might be increasing their interactions. We also looked at cardinal direction that the interactions took place, and so the north and west shores of an island tended to have many more interactions than the east and south. This could be due to beach accessibility or some other factors that we didn't get to look into. Finally, we got to look at environmental variables, and we did so using environmental data summaries of the ERDAP collection of satellite environmental data via the Coast Watch and Ocean Watch programs. And basically how this works is you take a specific point in space and time and you can create a box around it. And from there, you can compare that with satellite environmental data for the area around it. So let's say you're looking at sea surface temperature. If you have a specific point, you can take the average sea surface temperature values for the week previous, the month previous, the year previous, whatever time scale you want, and compare it to your specific point to see where it falls. We did this with 6 environmental variables, and those were sea surface temperature, surface wind speed, precipitation, chlorophyll A, KD-PAR, and KD-490. Using this methodology, we identified 2 environmental variables that seemed to have a driving influence, and those were chlorophyll A and KD-490. KD-490 is the diffuse light attenuation coefficient for 490 nanometer light, and this basically means how deep in the water column blue-green light can penetrate, and this is affected by particles in the water. So this is a good proxy for water clarity. Higher KD-490 values mean that the water is murkier, and so as you can see on this plot, we have these gray histograms in the back, and these are the 8-day average KD-490 values for the area surrounding a shark-human interaction. And then the dots along the bottom are individual shark-human interactions. And so 74% of these interactions occurred above the 50th percentile of KD-490, which means there was a tendency for these interactions to happen in murkier water. This follows conventional wisdom that says to stay out of the water after a storm or in murky water. There's a few reasons why this might be. It could reduce human visibility, so people are less likely to see or avoid a shark in the water. And there's also been some studies that indicate that sharks, especially tiger sharks, have some sort of preference for murkier water. This could be to aid in hunting or for younger, smaller sharks to avoid predation themselves. There's a lot of places we could go from here. We could combine EDX with beach use demographics to look at more populated beaches. We'd also examine the role of tourism more closely to see if when there's more tourists, there's more interactions. And also just we need to know a lot more about cookie cutter sharks. We don't really know a lot about them despite being such a globally distributed species. And thank you. That's all that I have. This is a cool video of a live cookie cutter shark. This kind of stuff is really rare. So thank you, and I can take any questions.
Wow, thank you so much. That was such a great presentation, and I can't believe you have video of a cookie cutter shark. I've never seen anything like that. We actually
Yes, yeah.
we've pulled them up, in plankton nets before. That's always an issue, and they end up cutting a hole in the net, and we have to ditch it. To see live footage of that is pretty cool, very unique. Did anybody have questions for Juliana? Feel free to throw them in the chat. I guess you did mention, I'm so curious about that northwest, how there was more interactions on the northwest shores of islands. Do you have any speculations to other reasons that might be happening?
Yeah, that was also really interesting for us because it's so stark. There was really very few in the east and south shores.
My
My
main
main
guess
guess
I
I
be
be would
probably
probably
something to
something
do
to
with
do with
beach
beach
access.
accessibility or usability. Like just thinking about like on the Big Island, more people are going to be going to the beach on the west shore versus like east and south shore. Or here, there's going to be a lot more surfers on the north shore. So that would be my guess, but that would definitely be something interesting to look into more.
Very cool. Thank you for that. And we had a question from Caroline. What was your most important takeaway from this experience?
Um, for me, I think it was getting to use the EDS code, that was really, really cool. And it's a very powerful tool that I had never heard about before, but it's really interesting to let you take all this satellite data that can be hard to work with on its own and make it a lot more usable.
Great, thank you. All right, we'll go ahead and pass it off to Kisei Tanaka, who was Juliana's mentor throughout this project.
Yeah, I just want to give a big shout out to Juliana, Dawn, Joy, and myself. Had a pleasure working with this very talented young marine data scientist from Hilo. Um, she kind of exceeded every expectation that we set on, and just amazed by just how sheer willpower to go through this terabytes of satellite data sets and building shark human database, merging those two together, deriving these super interesting conclusions in a very meaningful way. So big shout out. This is a really important findings, and we all are really curious to see how her career takes off from here. And I believe she will be staying this marine science field, and hopefully we'll see her works in the future. And yeah, congratulations. That's great stuff. Great stuff.
Thank you so much, Kisei. Yeah, it's always exciting to see what's going to happen next, right? We did have one other question since we have a little bit of time. Crystal was wondering if you're going to publish your findings, Juliana.
Yeah, actually, that was something that we're looking into. I would love to. That's the short answer.
That's great to hear. All right, with that, we're gonna move on to our next presentation, which is actually the last presentation of this.